Certainly, following Bob Hirsch's excellent technical presentation is a tough act to follow, but I appreciate the opportunity to share some of the water monitoring challenges faced by New Jersey following severe storm events in the recent past. An overview of my presentation, I'll be talking about the challenges that we have faced after 3 severe storms, Irene and Lee, which were close together, and Superstorm Sandy. I'll be discussing 2 types of water monitoring, one for our coastal shellfish harvestability for our waters. And for those of you that are not familiar, New Jersey is one of the top shellfish producing states in the country. I'll also talk about inland riverine flooded waters and the monitoring challenges that we face there. A quick key lesson, particularly in the freshwater inland waters from Irene and Lee. Most of the time I will be discussing the water monitoring following Superstorm Sandy and some unanticipated challenges that we faced with that storm, some solutions, and remaining unanswered questions. I'll also talk about the resources that we relied upon during this storm event monitoring, and some of the best practices that we used and still need. This slide shows the 3 extreme weather events that we experienced between 2011 and 2012. One of the things that I will mention is that there are many similarities with the storm events, but there are also quite a few differences. One of the many similarities is that in all cases we had flooding, power outages, sewage bypasses, sanitary sewer overflows, degraded water quality, and statewide shellfish closures. For the first storm, Irene, the precipitation pattern was quite different than Superstorm Sandy. The observed precipitation one day, which is shown on the map on the right, was fairly uniform across the state. The pink is 6 to 8 inches of rain statewide. As opposed to some of the other storms, particularly Superstorm Sandy, where there was significant range of rainfall from less than 1 inch to 12 inches in the southern part of the state where the storm hit landfall. So the first storm, Irene, was coastal and inland. Lake is both coastal and inland, but Superstorm Sandy really had severe coastal flooding. It was a tropical storm, one of the largest ever recorded. There were severe power outages for a very long time, causing tremendous impacts in water quality and sewage bypass. And also notable in Superstorm Sandy was the fact that barrier islands were inundated and breached due to the storm surge and waves. And storm surge was very significant in Superstorm Sandy. A key lesson that we learned from Hurricane Irene and Tropical Storm Lee, again in 2011, is the use of available emergency SOPs is very important. This was available for the shellfish monitoring, and as we had not been called upon to do much inland floodwater sampling previously, this was not available. We did some bacterial sampling in New Jersey after these storms, but that was primarily done by USGS for DEP. And it was very clear that more adequate preparation and planning, at least for the inland waters, was necessary. And we began development with our New Jersey Water Monitoring Council members of an inland waters flood monitoring plan, and then along came Sandy. These are some pictures, iconic pictures that many of you are probably familiar with, of the impacts of Sandy, ranging from the Jetstar roller coaster at Seaside Heights to the breach in Manaloking, shown on the lower right. There's also one picture thrown in here of the New York City subway. The rest of the pictures are from New Jersey. The devastation, property, and life is clear, and most of you are familiar with this. This slide shows the storm surge following Sandy throughout New Jersey, ranging from the waters in the northeast, including the Passaic River, and I'll talk about that in a moment, to Raritan Bay, Sandy Hook, which you see again up in the upper right portion of the map, down through the coast, along Delaware Bay, and up through the tidal portions of the Delaware River. The storm surge that was measured was approximately 9 feet above mean high tide, but the station failed during the storm, so it was definitely higher than that 9 feet, again measured at Sandy Hook. The storm effects of Sandy included significant surge, rainfall, inland elevated flows, but minimal flooding inland. Only one gauging station went above flood level for the inland riverine systems. The surge widely damaged municipal stormwater, wastewater infrastructure, and about 80 of our sewage treatment plants were affected and lost power for significant periods of time or were damaged. The picture below shows Passaic Valley wastewater treatment plant, one of our largest POTWs in the state, and that was flooded and inundated, and significant bypasses occurred out of that plant. Shellfish monitoring, the water quality monitoring after Sandy. It followed the standard operating procedure that they have. There was a statewide shellfish closure put in place in advance of the storm, as is routine SOP for such a storm. After the storm, there was implementation of over 47 stations had to be sampled for pathogens starting a few days after the storm. Due to structure damage, there was significant coastal flooding, power outages, and bypasses, significant increase in pathogen concentration. We used a fecal coliform water analysis as the basis for shellfish harvest criteria for reopening, and we also used a innovative tissue viral colophage criterion for reopening. It is known that viruses survive longer in water than bacteria, and in the past there had been a safety period added to when reopening could be done based on the bacterial analyses. And at this point, we're able to use a viral measurement to more accurately determine when it is safe to reopen the waters. In the past, that viral element, the safety period, would sometimes result in harvesting being delayed past the time that it was safe to reopen the waters. But use of this colophage allows a more accurate determination of when safety it is safe to harvest the waters again. And that colophage analysis has been approved, and that criteria has been approved by FDA and the Interstate Shellfish Sanitation Conference. The shellfish bed reopenings required very long-term monitoring, something a bit unusual. It ranged from 2 weeks to up to 5 months. The waters remained closed in this case because the tissue viral criterion was not being met. And it was determined that during this period of time, and the graphic on the slide is between October 1st and the end of November, Superstorm Sandy occurred in the middle. What you're looking at is temperature on the y-axis and the date time on the x-axis. And what occurred is that the waters cooled during this period of time below a temperature which shellfish have the ability to purge the pathogens. The availability of continuous temperature data was very important in this case to understand what was going on and why the waters could not be safely reopened. So challenges that we were asked to address and some solutions for the shellfish water quality sampling. There were very massive power outages, and they were to the state labs, to our field offices, to employee residences that would respond to this. The infrastructure was damaged at the boat ramps and marinas. There was debris in the waters in terms of the navigation of boats to do the sampling. We had limitations in access to our GIS maps and information on where the sewage bypasses and overflows were occurring, being able to link those two things. We had to sustain monitoring for a very long time, 7 days a week, and needed to seek additional partners. Some solutions include have to take a part in the lab facilities to provide quicker access to storm-related spill information. The continuous temperature data, as I said, is helpful in predicting and confirming the need for closures related to the shellfish purging ability. And it was necessary to partner with the shellfish industry, and they were very helpful in collecting samples. The resources used here were the standard operating procedures for shellfish closure and reopening, and criteria were available for both bacteria and coulissage as a basis for reopening the shellfish water. In transitioning somewhat to the inland waters and the riverine system, there was an advisory for both fishing and boating put on a few days after Sandy for recreational boaters, anglers, and crabbers, including some inland waters, including the Passaic River, which I'll mention in a moment. About a month later, this advisory series was lifted for many waterways. For inland floodwater sampling, they had quite a few questions. Where to sample, when, how often, which parameters? Is it a response plan for recreational use, say secondary contact, or is it a study of flood impact? Developing an inland flood monitoring response to Sandy, we lacked a flood-specific SOP, but we were better prepared after Irene and Lee. We received a management request to sample public access areas where there may be boating and fishing occurring that had elevated flow and sewage impacts. There were multiple potential objectives, but we focused on the secondary contact request we received from management, and we sought assistance from other entities in terms of flood monitoring responses, including EPA and USGS and other states like Iowa, my dear friend Mary Skopek, who will speak next. Here's one example of results that we obtained for E. coli. This is on the Passaic River. You can see that the Passaic River did not go over flood stage, but we did capture elevated flow, and we have 3 samples there. Below, you're seeing the results from those 3 days, together with historical data from the Passaic River location. The only samples that were above our primary contact recreation criterion of 235 per 100 ml are circled in red. You can see that the bottom on the left, that data is following Hurricane Irene, and that was what was collected by USGS. It went up to 14,000 mpn per 100 ml. Overall, the data was not particularly elevated. It was over the primary contact, but not really high numbers, and it did not, in these areas, did not go over flood stage. Water quality sampling during extreme weather, there are a number of field challenges, including collecting a representative sample, access to sampling sites, such as using bridges when there is debris, and safety concerns. Some of the challenges and solutions in the inland waters, again, preparing to sample with a field office that has no power. We were out of power for about a week here, and all sorts of questions came up. Things about lab emergency sample receipt and processing, whether or not we had the right kind of communication and documentation for quick turnaround samples with the laboratory that we use, which is our Department of Health lab, assuring personal safety, maintaining communication with our partners. USGS phone lines were down. We don't have a secondary contact criteria for inland waters in these areas. Some solutions, we have realized that we need paper copies of things, and not everything can be electronic. When you're losing power, you need to have paper copies. Reestablished some lab emergency protocols, made sure that all of our crews had sample containers and submission forms on hand in their vehicles. Sampling is delayed until emergency conditions cease, and we are only using 2-person crews for this. And we partner with other agencies where possible, and we have drafted an inland flood monitoring plan that we can use at this time. resources that are needed. We need a flexible plan to address management requests. You cannot predict what the storm will be like or where the problems will be. We should finalize our draft plan with our state council, and we need a secondary contact guideline criteria if we're going to put secondary contact type advisories in place. We gain knowledge from those partners that are listed here, and I think that it would be a good idea for the National Water Quality Monitoring Council to provide some ready access to inland flood monitoring practices that we could all use, and perhaps we could contribute something to that here from New Jersey. So overall planning and preparation for inland water quality sampling, set the purpose and the scope, make it flexible, develop the plan, develop safety preparations in advance, look towards predictive forecasts in terms of predicting the events 5-7 days prior, and then use these great tools that USGS has in terms of water alert, water now, water watch, predicting what is coming your way, also including some of the flood inundation mapping information that they have. And then implement your plan with partners, notify the lab, conduct the sampling. I'd like to gratefully acknowledge the folks in DEP and at USGS that did much of this work and are with me today, either virtually or physically here. Bob Schuster, who worked on the shellfish monitoring. Dean Bryson worked on the inland monitoring. Elena Baldwin-Brown worked on a number of different aspects of this. Joe Belinsky from the Office of Science, and USGS, my co-chair in the New Jersey Water Monitoring Council, Bob Reiser. Thank you very much for the opportunity to share some of our event challenges. Thank you.